Okay, good morning. This is your humble servant Kanga this morning. So today I'm going to walk you through how we can solve this land surveying question. So get your pen and your jotter and let's work this one out. So the question says that a magnetic azimuth of 54 degrees 30 minutes was observed along line AD in June 1977. The declination for the area surveyed is found by interpolation from an isogonic chart dated 1970 to be at 17 degrees 30 minutes east with an annual change of 1 minute westward. Compute the true azimuth of the line. So I'm going to explain the solution here so that when you get a similar question, you know how to go about it. So for you to be able to solve this question well, you should be able to draw the outline as being indicated here so that you know the directions of the magnetic declinations and the bearings. So first of all, here they made mention of a magnetic azimuth. So these words are used interchangeably. So it can either be magnetic azimuth, magnetic bearing, or magnetic north. They are referring to the same thing. But what you have to know is that we have magnetic azimuth and we have the true azimuth, or you have the magnetic bearing and you have the true bearing. They are words used interchangeably, but they are talking about the same thing or the same concept. So the true north here can also be referred to as the true azimuth. It can also be referred to as the true bearing. And the magnetic north here can also be referred to as a magnetic azimuth or a magnetic bearing. Okay, so what the measurement we take on the field are the magnetic bearing or the magnetic north or the magnetic azimuth. So whenever you're using your compass, the measurement you take on the field are the magnetic readings you take or the magnetic bearings you take, because we cannot refer them to as the true bearing because there are some errors that are encountered or incorporated into the um, machine when using to pick the coordinates. We have the local attraction errors because of the metals around. So whenever or the readings you take on the phone are the magnetic bearings. So you have to understand that. So in the question, they give us a magnetic azimuth or a magnetic bearing. They didn't give us a true bearing. So first you have to draw your cardinal point like this. You have your north, south, west, and east. Then the magnetic bearing is a shift from the true bearing. So you have to give some offset from the true north and draw a line like this one. So this one will represent the magnetic north. And this bearing, you see, for a normal bearing, we start measurement from the true north. So since this one, the measurement given to us is a magnetic azimuth or magnetic bearing, we will start the measurement from the magnetic north to the line. And you can see that the angle is 52 degrees and 30 minutes. So it's in between the first quadrant. So you have to draw your line AD, then you draw your arrow from the magnetic north here up to the north. It was 54 degrees and 30 minutes. note that this one is the magnetic bearing or the magnetic north. Okay, and that was in June 1977. We're taking the lines one by one. So the magnetic azimuth of 4 degrees 30 minutes was observed along line AD in June 1977. So now here is the magnetic bearing, and it is in what 1977. So we draw that bearing to the line AD. So we are done with the first line. Now let's move to the next line. He said the declination for the area surveyed is found by interpolation from an isogonic chart dated 1970 to be 70 degrees 30 minutes east with an annual change of 1 minute westward. So you have to note something here. We have magnetic declinations. When you check in my previous videos, I made some videos about it, how to compute magnetic declinations. So our focus here when we are dealing with the compass or compass surveying is for us to get our true north. So whenever the declinations are being given, we are all working towards the true north. So if the declination is to the east, if you want to get the true north or the true bearing, you have to measure to the true north. If the declination is given to the west, you have to measure to the true north. So that's what you have to note. And you have to note that whenever the declination is referred to be in the west, it is a negative declination. And when it is being referred to be in the east, it is a positive declination. So let's say I've been given a declination here. Now I have to get my true north. So the declination is the shift from the true north. So now I'm having my true north here. I'm having my what? My magnetic north here. So meaning that the difference between this magnetic north and the true north is the declination. The difference between the true north and the magnetic north is the declination. So by putting this small equation here, we can say that the true north is equal to the declination plus the magnetic north. So declination is the angle here. So meaning that if the angle or the declination is to the east, for you to get the true north, you have to add it to the magnetic north for you to get the true north. So get that concept. Now let's come to the western. Now if the declination is being given to be at the western side, meaning that we have to come back to our what? Our north. Our focus to get our true north. So now how can we get from our true north? Do you get it? Because the bearings are being measured from the north. Do you get it? So meaning that if it's being given here, for us to get the if the bearing or the magnetic bearing is being given here, meaning that it is what a shift from the true north. So meaning that our magnetic bearing will be somewhere here. Meaning that it's what a shift from the what? From the true north. Hope you get me. So meaning that for us to get our true north, you have to subtract that shift so that we will come back to the north. Now this angle has pushed the magnetic bearing here, or the arrow has pushed the magnetic bearing here, because our focus is to get the true north. So meaning that I have to subtract that small angle or that small declination that has pushed the magnetic bearing here to come back to the true north. So whenever it is what a western declination, it is what minus, and whenever it is what a positive what declination, meaning that we're talking about the eastern side. So understand these two concept. Okay, so now they give us the declination for the area survey to be 17 degrees 30 minutes eastward. So you have to know that this declination is in the eastern part. So meaning that, and we know that the declination, the shift between, or the angle between the true north and the what? The magnetic north. So you have to indicate that the angle between the magnetic north here is what? 70 degrees 30 knots. And we are not using this magnetic north here because when the interpolation was started, or was being used, it was started in 1970. So meaning that it was earlier before 1977. So you have to indicate that arrow to show that that magnetic north was earlier before the magnetic north, or the main magnetic was issued. So you have to draw an arrow to show that it was earlier before the 1977. So this is the declination in 1970. So from the magnetic north of 1970, the shift from the true north was 17 degrees 30 east. And now for the east, we measure to the north. You have to measure from north, this one to the north. That's why you're having 17 degrees 30 north here. So the angle between the magnetic north in 1970 to the true north is 70 degrees 30 minutes. All we get it. So now we've displayed the 70 degrees 30 minutes and the 54:30. Okay, so now the question says that there's an annual change of 1 minute westward. So now we should compute the true azimuth of the line AD. So now we want to compute the true azimuth of the line AD. Now they give us the actual magnetic bearing from 1977 to the AD to be 54. Now they're giving us the declination from 1970 to be 70 degrees. So you can see that you have to get that small declination here. So if you are able to determine this small declination in between the magnetic north of 1977 and the magnetic north of 1970, we will be able to get the correct or the true north for line AD. So now you have to consider, now they are saying that an annual change, meaning that every year there's an increment of 1 minute in the declination. So meaning that you have to know the number of years within this year. So you're having a magnetic north of you're having the years to be 1977 and 1970. So the difference between the 1977 and the 1970 is 7 years. So meaning that since it's an annual change of 1 minute, 1 minute multiplied by 7 will give us 7 minutes. Will give us 7 minutes. Meaning that the change here, or the declination between 1977 and 1970, is 7 minutes. And the 7 minutes they said is what? Westward. Do you get it? It is westward. And westward means that it's what? Negative. Westward means that it's what? Negative. So you have to note that. So that's a small shift here. That's a small shift here. So now if it is moving westward, meaning that it's coming to this direction, So we can draw our arrow from this here to this place because it was moving westward. Okay, so now since it is negative, we will have to end this one. The 17 degrees 30 minutes was eastward. So you can see that this one is positive and the 7 is what? Negative. So you have to subtract the 7 minutes from the 17. So you can see that we're having 17 degrees 30 minutes minus 7 minutes. And that one will give us a value of 17 minutes 23 17 degrees 23 minutes. So this one will be the correct declination of line AD since 1970. So this one will be our correct declination. So now we have deducted the 1970 from it, so it will be from 1977 to the true north. And we will know the formula that the true north is equal to the so if it is the eastern plus, if it is in the um, western side is what? Minus. So we have to add, since we want to close this gap, we want to push this magnetic north to give us the correct true north. You have to push this one to be added here. So by pushing, you have to add it. So we will add the difference here to the magnetic declination. That is 54 degrees 30 minutes. So when we add it, we will get 71 degrees, because when we add so 23 plus 30, so 0 plus 3 will be 3, then 3 plus 2 will be 5. That will give us what? The 53, then the 17, then the 54. So 7 plus 4 give us 11. So write 1, remainder 1. Then 1 plus 5 will give us 6 plus 1, 7. So we get 71 degrees 53 minutes. So that will be our true north or true bearing or true azimuth. I hope you understand it. If you don't get it, you can see me, then we'll go through it. So as time goes on, we'll go on solving more questions. And if you have any other question you want us to solve, you can just DM me with it. Then we will look at it together. Thank you very much for your time. God bless you.